Uh, Welcome, everybody, to the William W. Hay Railroad Engineering Seminar. We've had an outstanding semester of presentations from numerous great speakers on really important topics, and I'm pleased to say we're ending up with quite a bang here, because today we're going to be talking about long freight trains, ensuring safe operations, mitigating adverse impacts. And as many of you know, this has been the subject of long and increasing length freight trains has been a subject of some debate and discussion in the United States for the last several years. And as the abstract for this seminar announcement said, Congress asked the Federal Road Administration to retain the TRB to form a committee to study them, apply some science and engineering to the question. And they formed that committee, and two outstanding members of that committee were Paul Vilter and Peter Swan. And Paul is retired from Amtrak, where he worked from 1999 to 2022, and also before that worked with CSX and Conrail and even Chessie System. His co-presenter today, Peter Swan, is a retired associate professor of logistics and operations management from Penn State University, and he too had a railroad career with both Chessie and CSX. And both have spent their entire careers working in the topics of rail operations and safety and engineering and analysis. And so they were ideal candidates to serve on this committee and provide their expertise to these questions really related to long trains. And so we're very pleased that they agreed to present this William Hay seminar today. And so with that, I'm going to turn it over to Paul and Pete.
Great. Well, thank you very much, Chris. Great opportunity here today. I'm Paul Vilter. Pete and I are two members of this committee from the TRB. I'll start out and then throw it over to Pete, who will continue with the presentation, and then I'll wrap us up at the end, and then the two of us will be available to take questions. So we look forward to that part of this especially. So why don't we go ahead and get started? And if we could go to the first slide, please. All right. So as Chris mentioned, the Congress of the U.S. actually requested a study about long trains. And again, as Chris said, the mechanism they chose to use was to retain the Transportation Research Board, and I'm sure most of you on this call are familiar with that entity, to get a panel together to discuss this issue. And the things that Conrail or the Congress was interested in, they formulate in what's called a statement of task, and they essentially said, this is what we want a report about. And as you see on the screen, all aspects about derailments and safety, communications between locomotives and crew members, crew training, impacts on the public, especially with respect to grade crossings and passenger train operations, and greenhouse gas impacts. So this was what was in Congress's mind when they asked the committee to get together and look at the impacts of long trains. As you can see here from this slide, one of the fun things about serving on this committee, and all of us you see here as committee members did this on a volunteer basis. One of the fun things about it is that it was really a wide-ranging and interdisciplinary panel that TRB put together. Just to kind of run down the right-hand column real quickly, as you look at that, you can see that our chair was a former member of the Surface Transportation Board and also leader of the Kansas DOT. So we had state and STB experience. We have a couple members who are from Canada. As you see here, we have a couple academics, including my colleague here, Pete, and also Tyler from University of Texas. We had somebody from the transit side, DC Metro, also Teresa's former Amtrak. Another state person, we had folks from Class 1 railroads on here. We had former BNSF. As was mentioned, I'm from Conrail and CSX. Pete was from CSX. We had a retired NS person, as you see. We had a state regulator in the form of the Illinois Commerce Commission and academics. And so it was really a great experience to work with such a diverse group of people. And as is mentioned on the bottom left-hand corner of the slide, this is what was called a consensus committee. So what that means is that all of us from our different backgrounds had to come together and agree on all of the recommendations. And that made for some really interesting conversations. Next slide, please. So the statement of task asks for whoops, if you could go back one. Thank you. The statement of task said trains longer than 7,500 feet. But anyone who has looked at the report or is familiar with it realizes that we did not make any statement about the length of the train. We didn't limit that, and we didn't say that that was something that needed to be. I
This important thing on train length. How is it now, Paul?
think I'm back.
Okay.
Yeah, my apologies. I don't know what happened. Anyway, I'm in a different location with a different connection. Anyway, as Pete was probably going to say, there really wasn't a definition per se of what a long train is. The statement of task listed 7,500 feet. That appears to come from an AAR standard. But one of the important conclusions of this report is the committee did not seek to limit train length. We did not attempt to say, thou shalt never have a train longer than X number of feet. As you'll see, the basic theory was that long trains can be operated safely if it's done using best practices. Next slide, please. So the process was a 2-year timeline, started with a literature review of what's out there now. Pete's going to talk here shortly about data analysis done by the committee. Of course, the world was moving ahead while the committee was working, so the FRA and Transportation Safety Board of Canada issued some safety advisories while the committee was doing its work, and we took those into account. And there were a lot of presentations made to the committee to help inform our deliberations. Next slide, please. So one of the nice things about this process is that the committee could ask the TRB staff to please arrange for certain folks to come testify to the committee, and the TRB was able to reach out to stakeholders you see here on the slide, and they agreed to come speak with us. So we got a lot of input, as you see. Federal agencies, all of the class ones spoke with us. Amtrak and Metra also did. We had representatives from unions. We had folks who were particularly focused on grade crossings. We talked to people about technology for braking and communications. And we did a committee field trip out to Chicago at one point and got a lot of input from local community members out there. And really, I think, had the opportunity to hear from a lot of different stakeholders. All right, next slide, please. So what we did with that input, and I'm about to hand it over to Pete here in a moment, but we basically interpreted this statement of task to really focus in on 3 key things. We heard over and again that really the issue is not long trains per se. There have been long unit trains operated for many years. Those of you familiar with the railroad industry know that. Coal, grain, things like that. And that's been mostly uneventful. But in the last several years, and we'll talk about when we saw that starting to happen, railroads started running manifest trains of greater length. And as you probably know, a manifest train is a mixed bag of cars. You can have loads, you can have empties, you can have heavy cars, light cars, long cars, short cars, cars with cushion underframes, cars without. And the reason that the operation of long trains seems to have caught the attention of Congress is not long trains themselves, but long manifest trains, and the problems and issues that have arisen because they're much more difficult to control. So we decided to focus on long manifest trains and their impact on safety, highway rail grade crossings, and the impacts on another aspect of an impact to the public, which was on Amtrak passenger train service. So next slide, please. And Pete, I think we'll toss it over to you.
Okay, thanks, Paul. And Chris, I want to thank you for the opportunity to speak. It's important to the committee that we get as many people as we can educated as to what we did. So the report is fairly lengthy, and it was written so that aides who don't know the rail industry that in that great detail could read it and understand what was going on. The introduction is the statement of task and some other things in it. And then we start right off in talking about safety challenges and performance with long trains. After that, a little bit about the technology for controlling long trains, and to a large extent, this is a story about how technology made it possible to run longer trains. We talk about crews and training, and then we talk about effects on the public, which is grade crossing delay and Amtrak, and then environmental impacts. Now that we were charged to look at greenhouse gas emissions, but to be honest, we didn't have the horsepower to make that huge an analysis. And also, it was the committee's thought that the biggest change in greenhouse gas would be the railroads either losing or gaining freight. If they get more freight, it's going to take it off the highway. That's going to have a tremendous positive effect on reduced greenhouse gas emissions. We didn't see that long trains in and of themselves are going to make that big a difference. And then we went into the assessment and recommendations. And I think it's important to read those. Most of the press that we've gotten in this report has ignored the assessments and the recommendations. We spent a couple of years in this thing, and it's important to us that they get looked at, ideally acted on, but that may be too much to ask. So, as Paul mentioned, we concentrate on manifest trains. Unit trains don't have the wide variation in weight within a single train. So heavy cars pushing on a heavy car isn't that big a deal. Heavy cars pushing on a light car can cause problems. And not only that, you've got other things such as cushioning devices on couplers. You've got the length. There's a short haul, long haul problem you can run into. And all of this can make train handling much more difficult. So where the length comes in is the handling of the train gets exponentially more difficult when you're talking about running it over undulating territory. If it's just going up or going down, it's not that big a deal, but where you've got dips and things like that, it's a problem. And not only is the placement of cars important in trains, but it's also important on where distributed power, locomotives within the train are placed to control power, to control in-train forces, excuse me. So we wanted to have some data to look at this. And so we went to the STB R1 reports and looked at through trains. If you're talking about manifest, you're talking about through trains. Unit trains has its own category, local or way freight is one, and through trains is basically manifest and intermodal. Now the intermodal are very long, but aren't thought to be a huge problem. So there's a little bit of leakage of the intermodal in here. But if you look at the average length of trains of the four major class ones over the past 16 years, you'll notice that starting around 2013 and accelerating around 2018, the average size of these through trains increased dramatically. And this is kind of what we're looking for. The 2021 looks like it's a bit of a blip. I suspect that's COVID. But nevertheless, it continues up on the same upward trajectory going forward. Now, we compared this to the rate of derailments. Excuse me, and in particular, we looked at derailments involved with train handling and train makeup, which is the problem you can run into with manifest trains. And so we charted the rate based on billion gross ton miles, 2005 to 2021 again, and we noticed that, look, this chart looks remarkably similar to this one. Not exactly the same, but you see this, basically it had been going down and suddenly it starts up again. We wanted to take, and again, this is the four major railroads. We excluded CN and CP for various reasons, but thought we'd done enough data with BNSF, CSX, NS, and UP. So we then said, well, what about individual railroads instead of looking at the entire industry? What if we plotted a point with a derailment rate and year for each of the four railroads over these years, and you get a scatter plot like this. If you can draw a trend line. There's obviously some outliers here, but the trend line shows an increasing slope, meaning there's a positive relationship between the derailment rate and the average length of through trains in a given year. We then looked and said, well, what about the individual railroads? And so we did this again, but highlighted the different railroads. And you'll notice that the slope for NS is pretty steep. And there's a very clear relationship there. For the other railroads, in particular BNSF, there's an outlier and the rest are all kind of pretty tightly clustered. UP and CSX showing a positive slope as well, but nowhere near the increase that we're seeing for NS. So, this previously when people were looking at derailments, one of the problems you had was there's no good denominator, meaning we know the length of trains that derail, but we don't know the length of trains that didn't derail. And so this at least is a way of linking the train size and manifest trains to derailment rate. Now, what's important about this is the railroads started increasing the size of these trains pretty quickly. And in a high-risk industry, often they use what's called a safety management system. You look at marine, you look at air, you look at pipe, look at chemical companies. They all have instituted safety management systems. And the FRA adopted something that kind of falls short of a complete safety management system. They call it a risk reduction program, and it's still fairly new. But they specifically said, railroads, you need to look back and figure out what your problems are and reduce those risks, as opposed to when you're changing your operations, you need to mitigate the risks before you make the changes. And a true safety management program requires you to do that. So that to us was kind of a red flag as to why did this happen? Well, it happened because not all railroads thought ahead that well on what was going to happen when you increased the length of trains and didn't mitigate the risk. And so part of our conclusion that is the railroads were not sufficiently proactive, or systematic in controlling the risk from longer trains. And I will tell you, with the presentation, there was a wide variety in what the railroads did to mitigate risk from running longer trains. And so we concluded that the FRA's risk reduction program needs to be changed into a true safety management system. Now, these recommendations are paraphrased. I don't want to read these whole things, but as I've already mentioned, we thought that the RRP should be changed to be a true safety management system. And we thought the FRA should be active in auditing the railroad's programs, both to ascertain the method under which the program is run, but also compliance with the plan that comes out of the RRP process. Currently, when the FRA has done audits, they've audited the people in the plan, the people in the positions, that the things that are supposed to be done are done, but the compliance with the plan doesn't seem to be something that they really had their finger on yet. And for this to work, we felt the FRA needs to be able to do that. They need resources for auditors to review the railroad safety management system, assuming it gets changed. The field inspectors can also verify implementation. One of the things the railroads all have is rules for how to make up trains. And these rules have to be tailored to a particular subdivision. So we didn't think that we could specify what the railroads did as far as mitigating the risk of running longer trains. We felt they could do that on their own. But the methodology, the rules they use have to be well thought out. The systems they use to make sure that the trains are going to get over the road safely has to work, and they have to follow the rules. We also thought the industry needs to synthesize protocols and best practice. The last publication from the industry on makeup of trains was, escapes me now, something like 1992 from the AAR, and that was before the introduction of distributed power. So at a minimum, the risk reduction program needs to have train makeup rules and procedures for rigorously implementing them. And also, in many cases, we thought running a simulation, a quick and dirty simulation of the train to make sure it's going to make it over the road safe. The RRP needs to have a description of the technologies, DP, engineer assist programs, leader, and trip optimizer, and also braking system. we felt that assessments of skills and competence of crew engineers, both engineers and conductors, when encountering long trains and handling challenges needs to be done. There was evidence that not all engineers were skilled up enough to handle these long trains on their own. Certainly with Leader and Trip Optimizer, they could do a decent job, but it did not appear that all engineers were trained as much as they needed to be for handling these long trains. We felt the training methodologies and systems needed to be changed for that. So how to deal with that? Well, we thought the FRA should stand up some RSACs, Railroad Safety Advisory Committees. One, to look at training capabilities, competencies for the safe operation assembly of trains. And two, the current handheld radios clearly don't have enough power for crew members to always communicate with longer trains. You have to go back further, 2 miles, 3 miles. And the handheld radios line of sight often do not work. And while this isn't directly a safety problem, you can relay information to the dispatcher, or you can, following the rules, if you lose communication, there should be no reason for a safety problem because the rules take that into account. But certainly it has an indirect effect on safety. We thought the railroads with the FRA and maybe the FCC should work to find a fix for this. Okay, Paul, I'll let you take over here.
Thank you, Pete. So another of the areas of focus was blocked highway rail grade crossings. And as Pete was emphasizing, the committee, where it could, tried to use data to inform our conclusions. And we found that there are some data available about highway rail grade crossing blockages, mostly through a database that the Federal Railroad Administration maintains, where folks can voluntarily call in and report blocked crossings. But we felt that really wasn't up to the job. That's anecdotal, it's not rigorous, it's whoever feels like calling in and reporting a problem. So to try to augment that, we formed sort of a subcommittee to look at this specifically. We talked to several communities around the country and heard a consistent message that there is an issue here, that trains are blocking grade crossings for longer periods of time. And if you think about it, this appears to also be traced back in many cases to the issue of longer manifest trains as opposed to longer unit trains. Often a unit train, say a unit coal train, will go from a purpose-built loadout at a coal mine, essentially not stop on its journey to its destination, except perhaps for crew changes. Contents of the train, the cars are not usually switched in and out. It moves as a unit from the purpose-built origin to the purpose-built unloading place at the power plant or port, wherever it's destined. Contrast that with manifest trains, where you get a yard that is probably 100 years old, was built for much shorter trains. Crews are trying to create and put together a long train that might require doubling, tripling it out of the yard, causing a lot of blockage to any roads around that yard. Then stopping along the way to set out cars and pick up cars, and having the yard to train at destination. Again, the yard often is not prepared for a train of that size. So there's much more impact on the surrounding community to manage a long manifest train than a long unit train. And again, this is one of the reasons that this issue has come to the attention of lawmakers, because there are a lot of complaints about long trains. But we didn't find hard data. So you'll see one of our recommendations is going to be to create that data. Next slide, please. So basically, we oops. It jumped. We've also realized that we're in a kind of a limbo here, because the railroads have taken the position that the historic ability of state and local governments to regulate blocked crossings was unconstitutional, and they have won that argument in court. railroad, CSX in particular, in a case, State of Ohio versus CSX Transportation, asserted that federal law or the Constitution's Interstate Commerce Clause is what governs the regulation of railroads, and therefore state and local governments have no standing to fine railroads or otherwise encourage them not to block grade crossings. The courts agreed with the Class 1s. The Supreme Court of the US declined to take up an appeal. What was interesting about that appeal is the bipartisan support that it had. There were, I believe, 17 amicus briefs filed with the court recommending that that the Supreme Court take this up. And if you look at them, they're from red states and blue states, they're from interior states, they're from coastal states. It truly is a wide-ranging problem around the country, and a lot of folks are appealing to their political leaders to try to solve this problem. The problem with taking state and local governments out of regulating block crossings is that the federal government doesn't have any regulations about time limitations on blocking highway rail grade crossings. So we're kind of in a situation now where the railroads can manage this any way that they wish. And that led to our recommendations. So first of all, as you see here, we feel that the FRA should obtain data on an ongoing basis from the railroads on blocked highway rail grade crossings. And the study proposes some limitations around that. We would suggest that they use the grade crossing warning devices to transmit information on to the FRA, perhaps on a monthly basis, for how long roads were blocked, maybe only 10 minutes or more. In other words, FRA and Congress should set some kind of limit about which blockages are long enough to be worthy of reporting, et cetera. And that the FRA should then use this more comprehensive and rigorous data set to understand where is this problem happening and how often is it happening. And then, informed by data, the FRA should negotiate with the railroads to solve the most problematic sites. And we foresee an FRA leadership role here, but certainly states would be involved as well. But as most folks on the call perhaps are aware, that the FRA has some budgetary authority here to spend some money on grade crossing blockages as well. And we felt that FRA should also be given the authority by Congress to impose some financial penalties on the railroad. And the idea here is not to fine railroads per se, but the idea here is to create a little impetus for railroads to sit down with FRA and other local governments to solve this problem. A thread that we tried to have running through the committee's conclusions is that railroads are often best positioned to solve these problems, but especially in the case of grade crossings, and as we'll see in a moment, also Amtrak, they really, these are externalities. These are impacts on the community from the railroad's actions that the railroad doesn't really have anything within its economic sphere that reflects the impacts of what they're doing to the external world. So a fine is a method to try to say to the railroad, you can still decide how you're going to run your railroad. But if you create an external impact, for example, you block a grade crossing, and we heard examples of days even that crossings are blocked. If you're going to choose to do that, the committee is saying that the railroad should have a financial penalty brought forward to then make the railroad take that into account. And maybe if they're paying a fine and blocking that road is now expensive, then maybe they'll reach a different conclusion, which might be a capital improvement, might be sitting down with the FRA to make some improvements, might be cutting the train if they know it's going to be there for a long time, maybe rerouting, et cetera. So those are the recommendations with respect to grade crossings. And next slide, please. Kind of a similar situation with Amtrak delays. Again, Congress asked the committee to look at public impacts on the public from long trains, not just derailments and safety, but things like grade crossings and Amtrak. So Amtrak was one of the entities that provided testimony to the committee, and they demonstrated increases in passenger trains delays from many different causes that are tied back to long trains. Things like more broken knuckles, longer time, which is, you probably know, is a connection between in the coupler between cars. That can occur due to the increase in forces within a train that Pete described earlier, especially a manifest train with a variety of loaded and empty cars. Longer time periods required to repair damages like that, instead of a broken knuckle maybe being, a few hundred or thousand feet back in a train. Now, if you have a 3 mile long train, it could take the crew much longer to get back to the problem and repair it. Um, and also issues with meeting and passing Amtrak and freight trains. And there's locations around the country where the main line is a single track. There's a passing siding or multiple passing sidings along the line. Again, many of these were built in the past and were sized to the shorter trains that were typically operated then. And now you get trains, freight trains that are too long to fit in these passing sidings. So, and that can impact Amtrak either from attempting to meet one of these trains, where since Amtrak's the shorter train, it gets diverted into a siding and has to wait till the longer freight train shows up, or it can be a problem with Amtrak following long freight trains, where the freight train is unable to pull into a side track to let the Amtrak train overtake it because the freight train can't fit into the side track. Next slide, please. We got a lot of data from Amtrak, but we thought we'd just show one example here in this presentation where, starting around the same time that Pete mentioned before, Amtrak demonstrated to the committee that they saw a significant increase in the total minutes, and also on a normalized business basis, the number of minutes per 10,000 train miles that Amtrak runs. They saw an increase in delays following long trains. And so Amtrak provided a lot of information along these lines to the committee, but this is the one that we really focused on. So next slide, please. So that led us to our recommendations, which basically is to focus on, whoops, wrong direction. Thank you. Conflicts arise, and as we just discussed, and that basically this appears focusing in on all the things Amtrak suggested. The committee elected to focus in really on the idea that a railroad is in charge of dispatching. It knows when the Amtrak train's coming. It knows the length of the Amtrak train. It knows the length of the freight train. It knows the length of the sidings available, and on a single track route. And if the railroad chooses to put a freight train out there that it knows is going to interfere significantly with the Amtrak train, that would appear to be a violation of Amtrak's right of preference. And that takes you to a federal law. So our recommendation here, as you see on this slide, is that the federal government should give the FRA the authority to enforce through financial penalties these types of situations, and that the penalties need to be substantial, just as with grade crossings, so that the railroad will pay attention, and they need to be certain enough that the railroad will have to take it into account. Again, it's another externality. The railroad today may take its chances that it won't be called to account for delays of this type to Amtrak trains, but we're recommending that the FRA, analogous to grade crossings, put this type of externality into the railroad's decision-making process. Again, the committee is saying the railroad still dispatches the railroad. The railroad can put a freight train out there that doesn't fit if it wishes to, but there should be some impact to them, which hopefully would cause them to take that into account and perhaps reach different conclusions about how they're dispatching. So that pretty much takes us to a summary, and Pete and I will be available to answer questions. But let's just wrap it up here by saying that, again, the report does not call for a specific length on trains. Oops, Pete, I think you've on one slide too far back.
Fell asleep.
We do not recommend any particular length of trains. That trains, including manifest trains, can be operated safely if rules and procedures are sound. And this is important, that they're routinely followed. It's one thing to have great procedures built on best practices in a rule book, but if they're not followed in the field, then it doesn't really matter. And another complexity I think we touched on, but I'll reiterate it here about manifest trains, is that another difference from, say, a unit coal train, a manifest train will do setouts and pickups along the way. And that can change a very sound and best practice type makeup of a manifest train when it leaves its original yard. If it starts picking up blocks along the way, all of a sudden you've got empties and loads intermingled, and you don't have a well-constructed manifest train any longer. The rules and procedures that are adopted for safe operation at the beginning of a route have to be maintained throughout the course of the train's route. And again, wrapping up, we feel that the railroads themselves are the ones best equipped to make these trade-offs on a day-to-day basis. But to do so, the railroads have to consider all of the impacts of their actions, including externalities. So that's a quick summary of the committee's work, and the presentation has a link where you can access this. It's available to the public. You can download the report free of charge. You can order a hard copy if you wish. As I say, it's downloadable and available electronically. And we'd love to hear from this group and answer some questions.
Paul, there's a couple up. Let me address one of these because it's something I think is worth talking about with regard to fuel usage. We had two presentations from Class 1 stating that longer trains use less fuel. One was a road that had substantial winter operations and said they compared fuel economy in summer and winter and found out that, well, in winter we run shorter trains, and guess what? Our fuel economy is down. Therefore, longer trains have to have better fuel economy, which kind of ignored the fact that cold weather would influence it as well. Another did some simulation comparing shorter trains and longer trains and went to a great level of detail. But one thing they didn't do was alter the power that was used on the trains. And so there's this comment here speaks to the fact that trains are most efficient when locomotives are run at run 8 all the time. And so longer trains, to the extent they're powered with less horsepower per ton, are going to use less fuel per ton mile than shorter trains will. But it's also true if you ran trains not quite as long with less power, the same horsepower to ton ratio, you're going to have similar effects. The air resistance doesn't appear to be is huge an effect. It's horsepower to ton and running at notch 8s that makes the biggest difference. So we didn't see any compelling argument. I've looked at the data on fuel usage over the years, and it's been steadily economy's been steadily increasing, fewer gallons per gross ton mile. But it isn't just longer trains, it's locomotives, it's bigger cars, it's a whole bunch of things. You want to add anything to that, Paul?
I think that covers it.
Okay. The second one was on emissions, and so longer trains, may do a little bit better with emissions. But the problem you can very quickly run into with longer trains, if they're having more trouble going across the road, if they're having trouble meeting and schedules, you can run into service problems. And that could quickly result in a loss of rail traffic. If you look at where rail traffic is right now, it's been steady or declining for quite a while at this point. It's how much of that is the new current operation of longer trains, or how much is it in changing the economy, we don't know. But we do know that declines in service are going to have a greater effect from lost traffic than anything about train length. There's some more. Are you looking at the Q&A, Paul?
Yeah, I see there's one question about NS derailment rate. Why did the committee believe that it was higher than the other railroads?
Oh, okay. That's worth. So this is basically derailment rate for train makeup and train handling. It isn't all derailment causes. It's just one. that you would see related to how trains are put together. And so NS, when they're running an average through train of say 78 cars, they're running a derailment rate of 0.045 per billion gross ton miles. Nobody's even close to that among the other railroads. You look at UP here, and they're running 95 car trains on average, and their derailment rate is 0.015 per gross ton mile. And so, that's why we say that. And it's also for all the roads, it's clear that there's a positive relationship between the derailment rate for train handling and train makeup and the length of through trains, although the rate of increase was highest for NS, as you can see by the higher slope there.
See, there's another question in the Q&A about who ensures that railroad engineering departments have analyzed the interplay of curvature, superelevation, longer manifest trains, dynamic in-train forces, buff and draft over all their territory. Is this something FRA has left up to the individual railroads? I'd say the answer to that is yes. FRA has left that up to the individual railroads. That's not really how they did it up in Canada. The federal government up in Canada required more of a demonstration of the safety of operations before longer trains were operated than has been required here in the US. And that's really one of the distinctions that Pete was talking about earlier about why what we have in the US is not really a safety management system, because the FRA did not require that kind of in advance analysis. And it appears there's a certain amount of experimentation occurring out in the real world. And mostly that has worked okay, but sometimes that has resulted in some derailments and other problems. So to answer that particular question, yes, it is something that has been left up to the individual railroads up to this point.
Let me add a couple things to that. We had two railroads that were actually running trains through a quick and dirty simulator to see what the in-train forces were going to amount to and whether it was going to be safe to operate, looking at the pounds per square inch, thousands of pounds per square inch of pressure. And if it was over a threshold, I don't know whether it was 400,000 or 300,000, they would adjust the train to fix that. Every day, the railroads are running trains with leader and trip optimizer that do take into account curvature, super elevation, logger manifest lengths, dynamic in-train forces. So, we rely on the railroads to do that. I think, that's part of the suggestion of the safety management system or the risk reduction program is the railroads need to take all this stuff into account and need to make good decisions on how they're going to run trains, have procedures so that they don't let trains out that are going to have problems. So the next question is, you said NS derailment rate is higher for a reason. I don't recall providing a reason. I don't know that I said there was a reason, but the derailment rate again was for train handling and train makeup. Those causes alone, we threw out things like broken rail and the like that had nothing to do with train handling and train makeup. And so why is that? Well, to be honest, we don't know completely, because we tried to get some actual concept data to see what railroads were doing with their trains, and were pretty much rebuffed by the Association of American Railroads. So we never did get that. So in all honesty, I can't tell you why, although it's pretty clear to me that NS was putting trains together without a lot of thought on how to do it in the safest way possible. So that would be my guess, but I can't say anything for sure. Go ahead, Paul.
I was going to say, there's a question here about, are the recommendations getting traction in Congress? That's a great question, because Congress asked for this information to begin with. So far, no, but we have to sort of think about the political situation at the moment, which of course is the Congress that requested this is about to come to a close with the elections that just occurred, and a new Congress will be seated in January. So I think the extent, or whether or not, or the extent to which these recommendations get traction in Congress is going to depend on whether the members of Congress who asked for this information got reelected and are still there and are still interested. Also, FRA, will be operating under a different executive branch regime than it did before the election. And so there's a lot of forces at play right now in Washington, as we all know from watching the news. So whether the new Congress will pick up and take action on this remains to be seen. I would say, though, as I mentioned earlier, that on grade crossings, there's a wide range of interest in that topic that's coming from constituents up to their state level representatives. So my guess is that there will continue to be pressure on Congress to do something about blocked grade crossings. Not to mention, heaven forbid, if there's another major accident or something like that, that can also bring this up to the fore. But we'll just have to see what the new Congress wants to do.
So, question here on, did we look at stopping distances versus signal spacings? No, we did not. So, our mandate was safety and effects on the public, and engineering wise, we we didn't see that as being a great effect. Stopping distance certainly is lengthened, but signals are set up so that ideally so that you can stop a train in time. But we did not get into that for better or for worse. Somebody else is back on this fuel usage and basically saying that longer trains, it's easier to match the horsepower to the train length. And I suspect that's probably true. But the explanations we got from the rail industry were less than compelling. Yeah, if you did a good mixed effects regression but it's also true that you could tailor the train weight to whatever locomotives you wanted to run. Paul, you said you wanted to answer this one.
I was actually going to move on to another one, but
okay, go ahead.
I appreciate all these questions. It's great that they're coming in. There's a question about, did the committee consider the economic benefits to the railroads of longer trains? Yes, we did. The fundamental assumption by the committee is that the railroads are operating longer trains because they want to, because they're deriving benefits from that. And one of the reasons that the committee did not recommend a maximum train length or anything like that was partly because we didn't see a basis in the data to do that. And also because we didn't feel that we wanted to recommend something that would curtail economic benefits that the railroads are seeking. The approach we took was rather to say that the railroads should be allowed to seek those economic benefits and obtain them, but not at an unlimited amount of impact to the communities around them or to other users of the rail infrastructure like Amtrak. So our recommendation was take those external impacts, block grade crossings, Amtrak delays, which the committee identified, and bring those externalities internal to the railroad's decision-making process. And basically say, well, if you still decide that the economic benefits you're obtaining from blocking a grade crossing are worth it, and you want to just start paying fines, or you want to just for grade crossings or delaying Amtrak trains, this approach says the railroads can continue to do that. If that is still a problem that rises up through the political mechanisms of the state and local governments, and the state and local governments want to take stronger action than just levying fines, well, they can do that. That's what our political process is for. But the whole approach of the committee here is to recognize that railroads are operating longer trains because it provides economic benefits. They just should have some part of their decision making should reflect the external impacts of those activities on their other users of the infrastructure and on the public at large.
So, question here about, did we look at the relationship between other types of derailments and train length? And the answer is no. I've been looking at some of that more recently on my own, but to be honest, we had 2 years to do this study, and there were certain things we couldn't get into or didn't have time to. So the obvious culprits with derailments for longer trains would be train handling, train makeup, broken knuckles, and things of those nature. So we stuck with that. There's a lot of things we would have liked to have done additional to what we did do, but we just didn't have the time to do it. And, the thing to remember is all of us this is not a consulting firm doing this job. This is all volunteers basically doing it in their spare time.
There's a question here about distributed power to minimize in-train forces. Absolutely, yes. That is one of the best things about how trains are being operated today is the use of distributed power for that exact reason, that minimizes in-train forces. So, yep, we know that's happening, and that's a good thing. It also is good in terms of making air brake applications more effective and more uniform, because instead of just reducing the brake pipe pressure from only the head end of a train, the engineer can apply the brakes and send that message back to distributed power in the middle of the train or the end of the train or both, and open the brake pipe in multiple locations and lower the brake pressure to start stopping the train more effectively and safely. So there are a lot of benefits to distributed power, which the committee recognized and really likes.
Yeah. The other thing we learned that was news to me is with PTC, they're using a new protocol for locotrol, LXA, and it's much more robust. And part of it is what Paul was saying. When you make a pressure reduction in the head end, the DP power can be set to automatically do the same thing. I think it's the standard, as does any power in the rear that's distributed. In fact, pneumatically electric brakes, the benefits from them are not nearly as much now that you put DP power that automatically increases the propagation of an air brake application through the train, to the extent with pneumatic electric brakes don't provide you that much more. Although that's not an area we spent a lot of time in, but we did look at it.
There's a question here about regulating. Should the FRA develop regulations to compel railroads to adhere to their own makeup rules? I think the committee would favor that. And there's a few things packed into that question. One is, should railroads follow their own makeup rules? One of the things the committee talked about and Pete touched on is, well, should the FRA or someone like that be the one who makes up the train makeup rules and impose those on the industry? And again, this is a committee that was made up of a lot of folks who come from the rail industry, and we have a lot of respect for the rail industry, that it knows what it's doing. And so I think the questioner put it correctly to say, should the railroads follow their own train makeup rules? Well, yeah, we think they should, but, in other words, rules that they developed. But we also felt on the committee that there are best practices out there. You look at the outcomes that NS has had versus BNSF, UP, and CSX, and clearly some railroads are doing a better job of this than others. And although we feel like each railroad should have control of its own train makeup rules, there are also some best practices that really ought to be shared. And the FRA does have a role there. And also there should be a role for the FRA in terms of requiring, and this was part of our recommendation about inspectors out in the field, to see to it that railroads are following their train makeup rules, and not just when a train leaves the initial terminal, but as blocks are added and dropped along the way.
Let me add,
Chris,
I think
your
we also,
hand is up. Oh, sorry. Go ahead,
Yeah,
Pete.
yeah,
I see
no,
Chris's hand is up.
yeah. If you don't mind, if I can interject a little bit on this. As you guys know, we've been doing a deeper dive on the data, and I think we have some additional information to add to the story that we'll be, presenting in the not too distant future. But one of the things that's important to understand is that your data analysis, according to your slide, was from 2005 through 2022, but that assumes homogeneous behavior with regard to train length and derailments. And what the data are indicating is that in the most recent years, those train handling derailments have actually come down precipitously, including for Norfolk Southern. So it looks to us like NS may have had a problem, but they understand the solution to that problem, and they've implemented it. So it's important to understand that just looking at one block of time doesn't necessarily say what the current situation is, which I know you guys certainly appreciate, but I'm saying that for the benefit of some of the questioners.
Yeah,
How are we doing on time, Chris? Oh, sorry, Pete.
We're fine.
Okay.
So there've been a couple comments here, the CSX case and IPVTA. What we envisioned is that there'd be a law passed that would enable FRA to do what we want them to do, which should give them the authority to do this sort of fines on grade crossings. And as far as train makeup, we envision the FRA auditing the process by which railroads make up their rules for train handling in the various subdivisions. So there'd be some oversight. And then we suspect that the field people could levy fines for infractions against the rules, much like placement of hazmat cars. An automatic fine for a hazmat car against the engine of certain types. Could see something like that working in the future. Oh yeah, it's just a question about unexpected brake application. Yeah, we talked about that a little bit. The train makeup, including DP power, is going to mitigate at least some of the problems with an unexpected brake application, because where you put the empties with regard to the DP power, with regard to loads, is going to make a lot of the in-train forces either worse or better.
Another factor to this particular question about, are things like undesired emergency applications, independent of train length? Well, that sort of assumes that the entire fleet is in perfect working order, which it isn't. And so if you have a train of, say, 50 or 100 cars in it versus a train that has, say, 300 cars in it, the chance of having a kicker or some other car that's got, issues with its brakes in any particular train is going to be higher. You've got fewer trains, but each one's longer. And so, the chance of having a problematic car in a 300 car train is greater than in a shorter train. So if every car were equally mechanically correct and in perfect adjustment, then I agree the length of the train wouldn't really make difference in the way the questioner is suggesting. But unfortunately, there are cars that are problematic, and you have a greater chance of having one of those in a longer train. I don't see any more questions.
I'm just looking to see. Yeah, all right. So the last question is the one related to UDEs. Well, if there aren't any more questions, we can adjourn unless there's any final comments, you either of you would like to make about this.
Well,
I would just go ahead, Pete.
no, you go first, Paul.
Well, I would just comment to the question someone asked earlier, do we see this getting traction in Congress? The committee, one of the reasons it was a fun committee is that folks really believe in the railroad industry on this committee and really would like to see the industry succeed and thrive. And I think we really do hope that Congress takes into account our findings and that we feel that we're trying to help address some issues that have become problems with the local communities and others along the way with respect to derailments, block crossings, Amtrak delays. This is all done in the spirit of the railroads know what they're doing. They're best equipped to make a lot of these trade-offs, and we would like the industry to succeed. But we feel that the long manifest trains, the railroads can do better in this area, and we hope that Congress will take the committee's recommendations to heart.
Yeah, let me just add a couple things to that, Paul. Chris made the point that the railroads have improved dramatically on their derailments, or at least improved after the high point, and that's what I would have expected. I think that emphasizes our point that the railroads should have been able to, well, they were able to figure out what was going to happen ahead of time, but didn't. And so our point is changing the risk reduction program to a safety management system requires them to think about major changes in how they operate before they actually implement them. The other point I want to make is that with grade crossings in particular, the AAR's been a little flippant with their approach to grade crossing, and their comment is that, well, if we run longer trains, there's going to be fewer times that a train blocks the crossing. There'll be the same number of cars, and there'll be less gate up and gate down time because there are fewer trains. Therefore, it's proof that there's less total blockage time when we run longer trains. And that's absolutely true if all things are equal. But of course, longer trains, things aren't equal for a number of reasons we outlined in the report. And it seems pretty clear to us that where the railroads are doing things that affect the public, in particular grade crossings and Amtrak delays, there needs to be some incentive for them to fix the problem before the problem's going to get fixed. And currently there is no incentive. And so economically, when you have an externality, the best way to deal with that is to internalize that cost with the economic actor, meaning the railroads would have to pay some sort of fine or be subject to fines when they have fairly horrendous blockages. And they can make the decision then of whether they're going to block the crossing or not, as Paul said. That's the most efficient way, in the sense that what it costs the society, what it costs the railroad, make a choice that minimizes the total of those two costs. We believe the railroads are able to do that, but without economic incentive to fix problems with grade crossings, to fix problems with Amtrak, there's not going to be anything meaningful that happens. In a case in point, UP's come to agreement in Houston, as I understand it, on blockages there. There were some horrific problems. And the agreement is that UP will take some crossings and almost never block them. It's certainly not for horrendous periods of time. And other blockings, they make no guarantee, which helps the city because they know how to route vehicles to avoid blockages, which is a good thing. But it also says that other grade crossings, they're not going to care. Maybe that's the way to go, maybe not, but there's little economic incentive. The incentive there is press coverage, which we've seen effective at times in certain places. So railroads should make these decisions. They're the best position, but they may need economic incentive to make a better decision for the country. And Chris, thank you so much for letting us talk on this. I don't feel we've gotten the best press. Not many people have talked about the recommendations and findings. And I certainly, I think Paul appreciates the ability to talk to this to a wider group of people.
Well, it's us that would like to thank you. Obviously, it's a great honor and privilege for us to have you talk about this important subject. It's great for our students and faculty, and of course, the something like 180 people that are attending the seminar nationwide, and actually even in other countries. So really appreciate you guys taking the time to put this presentation together and take the time and giving it today. So with that, I think we can adjourn. I'll just mention that this is the last Hay seminar of the fall semester. We'll pick up again in the spring semester, either in very late January or early February. So best wishes to both of you and all of our attendees for a great holiday, and we'll see you next year.
Thank you very much. Thanks for the questions.
Bye-bye.
Thanks.